Welcome back again. Thought we'd work an example problem for writing functions. I'm sure you thought that add two numbers was a pretty exciting function. We will ask you questions on exams to write functions, and we thought we should practice a little bit more than just add two numbers. So the example that we're going to do, I called it powers of 5, mainly because I wanted to include a picture of Voltron. I had this when I was a kid. Man, this toy was the greatest. You could like shoot the arms off. It was amazing. All right, not really the point of this video lecture. Instead, what we're going to do is we're going to make a problem to do integer exponentiation. Some people, if they were going to do integer exponentiation, they might say 5 to the second power and try to use the caret symbol. The caret symbol is exponentiation in a lot of programs, MATLAB, Python, no, actually not Python, but it's not exponentiation in C, right? It's exclusive OR. In fact, if you exclusive OR'd 5, which looks like that, with 2, which looks like that, you would get 7. It would certainly not give you 25. So what we were going to do, as just an example problem, is we are going to write a function called integer exp. So this is exponentiation for integers. You're going to pass it two things. You're going to pass it in the base, and then you're also going to pass it in an exponent. So this is 5 to the second power. So this should give you back, in this example, 25. What we're going to do is we're going to pick a type for what's returned, a type for base, and a type for exp. I've got those listed on the next slide, so I'll just jump to it. And the types are as follows. The base is going to be an int. That's because, we might let you exponentiate a fairly big number, like, over 128. However, the exponents, we don't want to go to like, the 200th power. So we're going to just make it a char. We're going to cap you at 127. We'll say that's the biggest you're ever going to need to exponentiate something to. And then we're going to return a long, because these things get pretty big pretty quick. And I also kind of like that they're all different types, and it's a good example problem that way. Here's what I would like for you to do. Do two things. Create a prototype, like up at the top, called integer exp, and then make the function signature, which is the part down below. You don't need to write it yet. So just go see if you can do those two things. Should be 2 or 3 lines of code, and then we'll get back together. Okay, so I'm going to go ahead and do it. Hopefully you were successful. Shouldn't be too hard of a task. I'm going to go into my writing functions that I've been working in. I chose to just clean up some of the old code. You can certainly have old code here. It doesn't do you any harm. And what I want to do is I want to write integer exp, and it's going to get passed in an integer for the base and a char for the exponent. So if that's my function, then I'm going to need to make a prototype for it. And then prototypes, you can totally leave in the formal name, but if you wanted to, just to prove that you can get away with it, you can say just the type there if you were like, and that's totally valid. You don't have to say the name. Ooh, but you do have to return long. That was a goof. So it's going to take in a base, which is an int, an exp, which is an int, and it's going to return a long. All right, so go ahead and fix that. Next thing we're going to do, so we still need to write this function, right? But instead of writing it first, what we're going to do is we're going to add the code to call it first. So the code that we're going to, and I'll just tell you this, right? The code that I want you to type in to call it looks like this. So we're going to make an array with 14 elements. 14 is not arbitrarily chosen. It's because 5 to the 14th gets way too big for a long even. So we're going to do from 0 to 13. And we're going to call this function integer exp, and we're going to call it with 5 to the 0th power, the 1st power, the 2nd power, the 3rd power, the 4th power, so on and so forth. And we're going to store it into that array. So that array is going to fill up with the powers of 5, right? All right, so let's go and write that code together. So fairly easy. I'm going to say long array of 5s. Oh, I didn't harp on this last time, but I'm choosing to make this a local variable. And that's just because it makes my example a little better. If you wanted to, you could always make global variables at the top. The trouble with global variables is you don't ever have to pass them in and you don't have to pass them out. So I'm using locals just because I like it shows the value of functions better. But just to mention, you can always cheat and use globals to your heart's content. All right, so I'm going to say array of 5s. Each element in U is going to get filled up with integer exp, and it's going to be 5 to some power. All right, so that code should work if we write integer exp. Just to kind of start you off and just to make sure things are working so far, let's make a result and make it 1. Little hint to help you in the right direction on this function. And then we're going to return result at the end. So we actually can run it right now, and it should hopefully work. So I ran mine here. It popped up. There's not going to be any output, but we should hopefully, when we pause it, we should be able to see this array of 5s, and everybody in here should have a decimal value of 1. By the way, this screenshot right here, we're going to make you show it to us in the quiz tomorrow, but it better not say 1s. It better say the real values. So your goal is to write this function. So see if you can implement this to where it works for all the values. Just to tell you what they should be, 5 to the 0th power should be 1. 5 to the first power should be 5. 5 to the second power should be 25. And I think you get the idea. See if you can write the function. Okay, I'm going to write it as well. So I've written it before, so it will probably not be that exciting. Whenever I wrote it before, I decided to make a variable I. There are always multiple solutions to a problem, but the simplest way that I thought would just be to take result and times itself in the base. I use the shorthand syntax times equals, which is shorthand for just result equals result times base. So if I go ahead and run this guy, and then I pause it, I can look at my variables, and I can see that they look pretty good. So 5 to the 0th power is 1. Anything to the 0th power is 1. 5 to the first power is just 5. 25, and I mean you can check the first couple, and they all make sense. And then 5 to the 13th power is this guy here. He's the last one that fits in a long. After that, they kind of go overboard. All right, we just wanted to do an example problem. That's it for this video lecture. The next one, just to mention it, is totally optional. It will not be graded on the next one. So if you want to be done with this activity, you're all set. But if you want to learn more about functions and organizations into different files, you can watch that next one. All right, see you next time. Bye.